So I'm going to make this short video just to illustrate why some earthquakes last longer than others. So one of the factors we talked about for damage was length of ground shaking. And so I wanted to show you why in some earthquakes the ground shaking lasts for 3 to 5 minutes. In other cases we get earthquakes that only last for a couple seconds, maybe 30 seconds. And so what you're looking at here in this little YouTube video is there's a subduction zone here. So we're looking down on the surface of the earth. This is a map view. And this is where two plates are converging. So I have subduction here where an ocean plate is subducting under a continental plate. And what you're going to see here is that at the first initial rupture, we will define that as the epicenter of the earthquake. But in some cases where you have a very long contact zone, so remember, where these plates are in contact is linear. It runs all along here. There's two plates crashing into each other. So when it slips in one place, sometimes that can initiate slippage along that linear feature. So let's see. If you start the little video here, you'll see there's an initial rupture right here. And so that would be the epicenter of the earthquake. And so the red and blue are indicating P and S waves that propagate outward, cause ground shaking. And if that's all that ruptured, the ground shaking wouldn't last very long. But that doesn't always occur. So you can see that there's more ruptures occurring as the energy is moving along this long contact zone. So boom, boom, we keep getting more ruptures, more energy, more energy. And so these waves are constantly moving through an area. If you were living here, you got hit by the first wave, and the second wave, and the third wave, and the fourth wave. And so this whole kind of contact between these two plates is constantly rupturing. It's breaking, 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 breaking. And every break is releasing energy, which releases energy waves. And so here I get hit by more, and then I'm going to hit by this one and hit by this one. And these waves keep coming and keep coming and keep coming. So for very large earthquakes, we see this sometimes called unzipping, or this movement along the contact face between these two big plates. And you get just rupture after rupture after rupture. And finally, you get to a point where the energy that's being released from the rupture isn't enough to initiate rupture down the line, and it stops. But large earthquakes like this one here, this is from the 1964 earthquake, or like the 2011 Japanese earthquake, there's a large area of rupture. So even though we say, hey, the epicenter's right here, that's not the only thing that ruptured in these really big earthquakes. That rupture occurs all along that contact where the two plates are colliding, and it just ruptures all along. That can go either way, but usually over some distance, like I said, the energy that's being released isn't enough to initiate a rupture to the next part of that contact, and so it does stop. But this is how we can get long ground shaking on these very large earthquakes, because you have multiple ruptures even though we identify it as one kind of epicenter.